We are looking at inverse functions today, and what we want to do is we're going to take a regular function, f of x, and we're going to determine, first of all, whether its inverse is a function, and then we're going to look at its domain and range once we have done that. So the first thing we want to do in terms of trying to determine if the inverse of this function is a function itself is we have to apply what's called the horizontal line test. And in order to do that, we're going to need to graph that function. So what I'm going to do is I'm going to pull up my calculator, and I'm going to graph that function. And the function was the cube root. So I do control, and I'm going to do the cube root of x plus 1, and then graph it. All right, and as you can see, I have a graph of that function now. And so what I can do to see if it's going to be, the inverse is going to be a function or not, I'm going to perform what's called the horizontal line test. So what I'm going to do is I'm going to create a horizontal line on my graph, and I can do that by going to the menu, going down to Geometry, and I'm going to do what's called a construction here, and I want to do a perpendicular line. That way I can guarantee that this line is horizontal. I'm going to do a perpendicular line to the y-axis. So I click there, I put a line there. I'm going to turn that tool off. Now I can grab that line and drag it back down here, and as it crosses this function, notice it only crosses it in one place, no matter where I drag it. And if I extended it on out this way, no matter where it hits the function, it's only going to hit it in one place. So that tells me it passes the horizontal line test, and that the inverse of this function is actually going to be a function itself. So now let me go back to my board, and let's look at the function, and we're going to do this in steps. We want to find its inverse now. So the first step in finding the inverse is, first of all, I want to take the f of x, and I want to replace it with y. So I'm going to write it as y equals the cube root of x plus 1. That's always the first step. All right, the second step I want to do is I want to interchange y and x in my function. So where y is, I'm going to put x, and where x is, I'm going to put y. So let me change colors here so you can kind of follow this maybe a little better. So this now becomes x equals the cube root of y plus 1. So all I did was I looked at the function and I interchanged x and y. All right, step number 3 now is I want to solve this for y. And once I do that, that's going to give me my inverse function. So now I'm going to change colors again. All right, so I want to solve this for y. So I'm going to take the function after I've switched out the x and the y. X is equal to the cube root of y plus 1. Now, in order to get rid of the cube root, I'm going to have to cube the whole function here. But remember, this is also an equation with the equals, so whatever I do to one side, I must do to the other. So I'm going to have to cube the x on the other side as well. Once I do that, the cube is going to undo the cube root. They're going to cancel each other out. So now my equation becomes x cubed equals y plus 1. Now, remember, my goal here is to solve this for y. So one more thing I've got to do, I've got to get rid of the 1 on this side with the y. So what I'm going to do is I'm going to subtract 1 from both sides. That's going to give me x cubed minus 1 is equal to y. Now, one of the things that is kind of particular to me, I like the y on the left side, so I'm going to change this around and write it as y equals x cubed minus 1. And I can do that because of the commutative property allows me to be able to do that. So now I have one more step to do. Step number 4. I want to write this in inverse function notation. So to do that, I'm going to replace the y now, since this is the inverse function. I'm going to replace the y with f to the negative 1 of x. And the way that is read as f inverse of x is equal to x cubed minus 1. And so that's going to be my inverse function. Now, I want to go and check this and kind of see, because one of the other properties of this, of inverses and its functions, is the fact, let me pull my graph back up. When you graph them on the same graph, they are mirrors of each other across the f of x equals x function. So I want to demonstrate that to you and show you here with the graph. So let me see if I can get rid of this. I'm going to drag it down kind of out of the way. So now I want to graph the function, what I call my mirror function. So I'm just going to graph x. And see, that's going to be my mirror. It's like putting a mirror here on the graph. And so when I graph my inverse, it's like I've taken this graph and mirrored it across to the other side. So you'll see that in a minute when I graph it. So now I'm going to graph my other function. So tab to get my function bar back. And remember, it was x cubed minus 3, or minus 1, excuse me, minus 1, and enter. Now, look at the two functions. This function is a mirror across the f of x equals x of the original function that we started with. So this gives me a picture to verify the idea that I have functions that are inverses of each other.